So welcome everyone to the March edition of our VAST Office Hours webinar, or I should really say pre-GTC, pre-NVIDIA GTC webinar. There's a lot to cover this week. We have a lot of announcements. So I think we're probably going to jump right into it because we've got a lot to cover. Again, these are interactive sessions, so ask your question using that Q&A button and we'll get to your topics. So with that said, I want to introduce you to our team. We've got the right team here to walk you through everything. This team has been deep in GTC prep. So we'll start with Rupert. Please introduce yourself, and then let's just go around the horn, and we'll keep moving here.
Hi, everyone. Rupert Menezes. I'm a field CTO for AI and emerging technology here at VAST. Thank you for joining us.
Thanks, Rupert.
Hey, guys. Niloy Bhattacharya. I lead solutions engineering focused on AI and HPC. This has been a big week for us. Next week's going to be even bigger. So very excited to spend a little bit of time with you guys.
Perfect.
Hi, I'm, excuse me, Jesse.
Jason, go ahead. You started. Go ahead.
Sure, I did it already. Jason Russell, technical director in the data and analytics group here at VAST.
Hey, hi, guys. Thanks for joining. My name is Jesse Thalur. I am the CTO. I lead the global system integrators business at VAST.
Excellent. So like I said, this is the team to ask your questions for, but given everything we did last week, I want to ask a question and see where everybody is. So VAST has been in the news a lot lately, and usually these sessions are a mix of current customers and new customers, but we know there's a lot more people coming on. So I want to get a kind of a level set here just real quickly. Looks like, about what we expected. So in the middle here. But again, if there's a question that we're not covering that you'd like to have covered, ask it in the Q&A, we'll get to it. But let's go ahead and jump right into this next one now. So
Nice bell curve there, Steve.
yeah, I think so. Perfect. So again, these sessions are all about your questions. They are the most interactive and most fun when we ask questions. So hit the Q&A button. And what I'll do is I'll read those and I will ask the team to answer those questions. Today, we've got more content, I think, than we've ever had before. So if we can't get to it, we'll follow up with you, hopefully in person next week. And that leads me to our next question. Are you going to GTC? And we certainly hope you are. So fire up that poll and let us know if we'll see you in person. Let's see. And I do hope that you all bought lots of NVIDIA stock a few years ago, or Supermicro. Okay, yeah, I'm not going either, but this crew is, so you'll see them. It's about 9% bought the stock. So at this point, I want to pass it over to Niloy. So Niloy, you've been just, key at helping a lot of our customers move kind of like through this inflection point from like AI as a concept to AI in production. What's like the most critical thing for people to understand, or what gets the most focus that maybe people need to consider a little deeper?
Yeah, no, absolutely. So the first thing I want to make an observation on the poll here, it does seem like a lot of you are not going to be there. So I want you to understand that all of these demos are available to you through any number of VAST contacts, right? If you have a salesperson you're working with, that person will be able to get you access to these demos. If not, we've got a great inside team that will respond to you if you reach out to us. So, rest assured, we're not actually going to be doing the demos today. That would take longer than the hour that we have here. But we're going to preview to you what we're demoing. And if anything sounds interesting, please definitely take advantage of the follow-up that Steve's going to put at the end of this little session today.
Exactly. Well said.
All right. So let's get into AI. And the news in the market certainly has all been about GPUs, right? GPU availability, GPU, knowledge and skill set, people from academic backgrounds finding, great opportunities, enterprise, all of these kind of topics. But when you get into AI, one of the things that you realize is that AI is truly a lot more about data than it is about the GPU. Right. And it's fairly simple paradigm, right? If you think of a neural network as a facsimile or an emulation of a brain, we learn by observing things from the external world, right? We learn by testing and doing some other things, but a lot of what we learn is from observation. So very similarly, AI does really well when you present a lot of data to it, and it can learn from that data. Now, the data comes in many different forms, and there's a lot of manipulation that has to be done along the way. And so that is what we're going to focus on over the course of today and in these demos. We're really going to kind of get into how VAST can help each of these phases of the AI pipeline and help you interact with data and with your environment. So with that, put a poll question out there. Which aspects of the pipeline are you involved in? Because one of the things that we find is many people don't actually have an end-to-end view of this world, right? Folks tend to have, this is the piece that I focus on, and gaining an end-to-end understanding is actually something that at VAST we're very much focused on.
That's a really even distribution. So
Even
I kind of wonder,
distribution, right?
are people picking all of them because they actually do all of them, or we just got lucky and got like somebody from every single aspect? It's interesting.
I don't know. It is interesting.
Yeah.
Well, this makes the demo even more interesting. So
That's right.
thank you for that. All right. Now
I just like that model serving is keeping up with data capture.
Yeah.
So for those that are not familiar, what is VAST? VAST is a data platform. What does that mean? It means many different things to many different people out there. At its core, VAST has a data store, right? So we are the persistence layer for data. We make it so that customers can store their data on our data platform. However, we then go beyond what almost anybody else in the industry, I would argue nobody else in the industry goes where VAST goes in this, in that we, enable you to consume this data via numerous protocols, all of which have been optimized for various use cases, right? So we have NFS, but then we have GPU direct storage, right? We have S3, which is a really cool use case when it comes to AI, because in many cases, data capture happens through some sort of an object protocol, whereas training and inferencing and all of those things are using NFS. So having a platform where you natively, the data is stored in a native format, and then, which isn't one of file object or any of these other ones on the screen. And then we're able to take these native elements and expose those via all of these protocols, makes it very versatile for the work types of access that AI needs. Also, we go well beyond what most other platforms do, right? So we have a tabular format that you can store data in. You can interact with that tabular format with SQL, but also with Spark and Trino. And Jason's going to get into some of that in his demo here in a second. And we have a data engine, right? So you can actually stream events using protocols like Kafka, or you can actually action on data based on, a certain particular pattern that you see hit your data platform. The last piece, and you're going to see this highlighted in several demos, is the vast concept of a data space, right? So in most workloads and in most environments, people spend an awful lot of time moving data between platforms, moving data between regions and sites where various compute resources may be available. Well, with vast data space, we seek to eliminate a bulk of that movement. The way we do that is by sharing the metadata layer so that all VAST clusters, regardless of where they sit, are all aware of the same data at the same time. They're aware of it, okay? It's not replicated everywhere, but everybody has knowledge about it. And so when you have various jobs that occur in various sites, we are able to move only the data that needs to be moved for that particular operation, instead of what happens in the majority of cases today, where data is essentially pre-staged for the potential of doing something useful with it. And of course, as we all know, most of the cases that data just sits there and there isn't anything useful done with it. The vast data space is very important, especially in the world of AI, where your GPU resources are not all going to be in one location, right? The nature of GPUs, whether you're using it for training or serving, is that they're going to be spread out. You're going to have to leverage different sets of resources to meet your SLAs, and the vast data space is critical to establishing that capability. Also want to draw attention to a piece of news that we announced earlier this week. This week, we announced our partnership with Supermicro and our first iteration of a platform where our logic functions and our persistence functions are now able to co-reside on the same technology. We actually originally introduced this with the hyperscalers. This is how our implementation in hyperscale environments works, and you are now able to take advantage of that on premise. So for those of you coming to the show, you'll see a lot of noise about this. For those of you that are not there, definitely reach out to us. So we've been in this AI pipeline space for a little while now, right? Those of you that have been following VAST, we have some very significant deployments, a little bit over 10 exabytes out there in the market. And earlier this year, actually late last year, we really started to ask ourselves, what are the barriers to adoption, right? We have the data platform. We have customers that are leveraging the data platform. What are the other things that are making it difficult for customers to get moving and extracting business value from AI workloads? And one of the things that we learned was that having more of a full stack solution is important to our customers, right? So it's not only enough to have the data, it's not only enough to have the GPU servers, but how do you start pulling these pieces together? And so earlier this year in February, we announced our partnership with Run AI, and Run AI really helps on the operational aspects of the platform, right? In enterprise environments, as opposed to HPC environments, you have a lot of parallel work that takes place. You have a lot of resource contention. You have many different groups that are trying to execute many different aspects of the AI pipeline in parallel. So traditional approaches to workflow management like Slurm that are used in HPC environments don't really map well to enterprise environments. So obviously, we've always had our longstanding partnership with NVIDIA. We're well integrated into NVIDIA Enterprise AI for Enterprise. But what AI for Enterprise doesn't do, this piece of data operations and ML operations, and that's where we have our partnership with Run AI. So in all of our demos today, you are going to see us highlighting our partnership with Run AI and how Run AI can be used to manage the workload environments that you are sharing. So getting into the demo environment, I know this is a busy eye chart, but this is the reality of AI workload environments out there, especially if you're a service provider, right? You're going to have multiple GPU-based platforms. So at the very bottom, you have the E-box. Then you have multiple GPU-based platforms, right? You have the 8GX, you have the OVX, and you have the MGX. 8GX is well-tuned for model training. OVX is well-tuned for model data preparation. And MGX is well-tuned for model serving. So you have different GPU-based platforms. They're not all the same hardware platform. You then have different operating environments, right? You have customers who at an enterprise level have standardized on OpenShift for Kubernetes. You also have NVIDIA's BCM. And for those customers who have standardized on NVIDIA, they use a base command manager, and they use Kubernetes managed by BCM. So we're going to showcase both of those environments. We won't spend as much time on the actual Kubernetes aspect in our demos, but you're certainly welcome to come and talk to us about that at the show, or like I said, we can set up meetings afterwards. Then we get into sort of the ML ops and data ops layer that I just talked about. And then we have actually two cool demos, just purely from a demo standpoint. We have a moment detection demo that focuses on video and identifying interesting moments in video using natural language queries. And then we have the NeMo framework from NVIDIA, and we have a model serving demo based on the NeMo framework. All right, so enough of me talking about background. Jason, if you want to, so we have 3 demos with data preparation, model training, model serving. We're going to start with data preparation. So Jason, if you want to go ahead and tell us a little bit about our first demo.
Sure, we're going to talk about data preparation a bit, which is near and dear to our hearts, being that it is a bulk amount of data. This is actually where a lot of the work happens. You need to prepare to train models. You need to prepare to have models exist into the future as time goes by, and get up continuously updated. So this is where a lot of the data is and a lot of the initial work happens. And so we're going to have a lot of processes that happen during this pre-processing section. We got our initial data landing and extraction. This is all the bulk data that we just have to start with our whole project. And then we're going to do a whole bunch of processes on it in order to prepare it for the training portions of the workload. So we got regular things like deduplication. We've got like since this is language, we're going to be talking about sentence detection, spelling, how we want to deal with that, chunking, eventually tokenization. Just the whole range of processing that can vary depending upon your workload. The tools we're going to use for this are, of course, Apache Spark. This is the the principal tool in this processing ecosystem. The reason being is it supports an ecosystem of libraries in the ML space. We're going to use Spark NLP, natural language processing, to do a lot of the work. MLlib, of course, built into Spark. I'm going to do it in Python because I like Python. That's what I use. That's what I know. But also, I'm going to use Rapids. And we're going to use the vast database. And these are the 2 important parts of this process to us. I think we can go to the next slide. Thank you, Neela. We're going to use Rapids and the vast database, and those are outlined in this particular slide. If we want to look at what this physically looks like. Neela talked about the data platform and the data store, and so the data store being the unstructured data store that everyone knows and loves, S3, NFS, SMB, raw data lands here. The important thing about the data store is that, as Neela intimated, it is a single namespace for all of these protocols, which is really handy in these kinds of environments because things may land via S3 and may need to be processed via NFS, and it's all the same space. We're going to have a Spark cluster here outlined at the top. This is a physical layout. That's going to be running the GPUs. It's going to be running Spark. It's going to be running all the associated Spark libraries. It's going to interact with the data store over NFS and S3. And it's also going to interact with the vast database, which we haven't really talked about much yet. This is a tabular data store on the same vast data platform. It's a peer protocol that Spark can natively access in order to rapidly do scan, filter, and project of data. What this means is that Spark can spend its time doing computational work, and VAST spends its time doing the scan, filter, and project, the actual finding of the data. So in this portion of the workload, we're going to do processing, we're going to split things up, we're going to chunk it, we're going to stick it in the database, and we're going to go on to future stages of the workload. I think we can go to the next slide. So a little bit about the technologies being used here. First, we'll talk about Rapids. Rapids is a glue between, in this case, Python or PySpark and CUDA. Basically, what it means is that you can GPU accelerate existing workloads for Spark. Pardon, Jesse? Existing workloads for Spark. So this means that you do not need to change any code at all. So if you have a workload for Spark or PySpark that uses the data frame interfaces or Spark SQL, Rapids will accelerate this geometrically. Actually, it's very profound, the acceleration you can get out of Rapids. Unless you're just programming at the RDD layer, if you're some codger that just does that, it won't do that. But once it bubbles up to data frames and Spark SQL and Spark, you're going to get acceleration. The nice thing about this is anywhere you have GPUs and anywhere you have Spark, all you got to do is load up a jar that is the Rapids accelerator, and suddenly you are off to the races. And these exist in all the hyperscalers and conveniently also VAST. Let's look at the proof here in the next slide. Oh, well, before we do that, I guess the pretty pictures are always nice. This is a Supermicro, an NVIDIA certified Supermicro OBX. If I'm counting right, that is 10 monstrosities of GPUs in the same in the same box. Go ahead and go over to the next slide.
I think this helps explain to people that the L40S is the GPU and the OBX is the platform that the GPU sits in.
Yep.
That was the entire point there.
So this is the good slide. This is the fun slide. So what we're doing here is really proving the sort of the synergy. I just used the word synergy. I'm sorry. A really good relationship between VAST database and NVIDIA GPU support. These are two great tastes that taste great together. We have some benchmark results here on the left, and we have a visualization here on the right of what they're good at. NVIDIA's GPUs are extremely good about doing joins, aggregations, anything that involves compute. Over here on the right, we have VAST that does the scan, filter, and project selectivity. So when Spark nodes are accessing a VAST database, they're sending a query plan that's getting back a very small amount of data. So getting back only what you asked for. And this is really important in these kinds of workloads. NVIDIA, on the other hand, does the joins, aggregations, and the compute that happens in this cluster. So what this means is you're getting the best of both worlds. NVIDIA is not spending its time scan, filtering, projecting, and VAST isn't spending its time, doing joins and aggregations, because that's what the GPUs do very well. We have on the right some benchmark results. These are TPCDS benchmarks. Everybody hates TPCDS benchmarks because they're very difficult. Any sort of parallel workload or any sort of hyper accelerated product is always not necessarily going to shine the greatest in TPCDS because there's window functions in the SQL and these benchmarks that just brings a whole cluster to its knees while it's waiting for a single thread to finish ordering something. But what you see here is an unaccelerated workload for Spark Hive, and by Hive I mean Hive metadata store on Parquet data. We have a Rapids accelerated Parquet Hive metastore workload for TPCDS, and then we put VastDB and Rapids together, and we more than halved the wall time for completing that benchmark. That does not tell the whole story because that's the whole benchmark all together. If we go down a little bit, we're looking at the top 10 or top 8 query performances in terms of the delta, how much they were accelerated by combining the VAST database and Rapids together. And that is profound. That reduces some of these times. Like if you look at query number like 70 or 42 there, we go from 79 seconds to background noise. 2 seconds is how long it takes to even get the query going. So that is a super profound acceleration that we got out of that, putting these two together. And the reason for that is what you see there on the left, VAST working on the selectivity portions of the query, and NVIDIA or the GPUs doing the compute, the aggregations and the joins.
But that leads to a really good question from Mark Weber. So he's asking about where the data is being processed. So VAST had features or processing or pre-processing the AI data. Does VAST hold the data and an external server processes it, or does it actually get processed right on us directly? Like, where does this occur?
Oh, I think that's the subject for a breakout session. In fact, I mean, you can think of VAST as a black box, and you can think of VAST as a table format in this case, much analogous to say like an iceberg or something. And so what we have is a Spark cluster that's external to VAST that's doing this processing that can natively access the VAST database, which is housed in the VAST cluster. So these are two separate layers. And certainly at GTC, we'll be happy to talk about the details of that architecture.
I think this is a good example though, right? So by having that externally based GPU cluster and Rapids, the computational aspects of the query can be accelerated, right? You wouldn't necessarily have GPUs within your VAST cluster. But at the same time, I think there's many scenarios we find where customers need to do some simple operations where they don't want or need an external compute cluster. And so as Jason mentioned at GTC, we will be talking more about our data engine capability and really kind of helping our customers find that balance of what do I run on the platform and what do I run external? What really makes sense from a workflow standpoint?
Yeah, I would add also that traditionally, most of these operations are batch-oriented in pipelines. If you look at most pipelines, they're drawn sequentially from left to right. The modern approaches that VAST enables is to do these things in parallel as opposed to waiting for sequential. So as data comes in, pre-processing and processing gets triggered on the platform, the bigger stuff gets batched off to a compute cluster, whereas the medium to smaller stuff gets handled inline. So as opposed to doing everything sequentially and batch oriented, you can now basically approach it in a parallel multi-processor focus, so to speak. So instead of one big data pipeline, now you have several micro pipelines going on at the same time. Just gets you to science faster.
Yeah, another quick answer to a question. Sorry, go ahead, Jesse.
No, I was just going to add one other aspect to this, accelerating these queries, right? If you're using GPUs to process any of these things, you don't want the GPU time to be idle waiting for the data to come in, right? And GPUs being very expensive, you don't have a lot of options to go there. So the most efficient way is to have your query be as fast as possible. And that's what our platform offers for you through our tables.
Yeah. Just one more quick question that was that came across on the panel. The VAST Data Engine does leverage compute resources within the VAST platform. We don't, at least today, manage external compute. We leverage resources within the compute platform. And so when it comes to solutions development, system engineering, architecture, that is essentially the crux of the issue, right? What operations and what parts of your pipeline does it make to run adjacent immediately next to your data on the VAST platform versus what things make sense to run externally?
Yeah, I had one clarification on the compute side, because I hear these questions coming from my customers all the time. When we mean compute, we're talking about basically Intel compute. Okay, it's basically Intel chips sitting in on Intel server and accessing the data through a high-speed backend network, right? There is nothing special about compute when we talk about compute in this respect.
All right. I think, Steve, it's time for a poll.
Yep. So we want to go ahead and ask if you are leveraging GPUs today as part of your workflow. We'll see how that goes. So one important point, though, about the way a VAST cluster is built is that you can scale compute and capacity independently. So if you do have a workload that needs more compute, you can add more of those essentially front-end boxes. Is that correct?
Certainly.
Yeah, you absolutely can.
Yeah, the table format itself is scalable, and that the VAST cluster itself is scalable, and of course the cluster of Spark is scalable, at least insofar as you have GPUs.
All right, so pretty much everybody's at least tried it here, right? Or they've got somebody else's
Well,
job.
yeah. So it's either somebody else's job or you have tried it. So yeah, it's good to see. It's more than it's always hard for us. We talk to a lot of customers, but often in the pre-sales realm and things like that. So what's actually going on out there is always good to see.
That's interesting.
All righty.
All right.
Let's move on to model training. So another pretty picture slide, but I think it's important for a lot of folks, guys. What we see in the market is people hear these terms, but they don't necessarily understand how the pieces come together. So we wanted to help do that here. So yes, in this model training section, we're going to be highlighting the Supermicro HGX server, which is the OEM version of a NVIDIA DGX. Built within it will be NVIDIA H100 GPUs, and also launched earlier this week, our Bluefield 3 integration, right? So the Bluefield 3 integration is an example, right? Jesse was just, or maybe Jason was just talking about scaling compute. This is a classic example of how the VAST architecture is able to scale the compute or processing layer associated with data. And here, we're able to do it by putting a DPU directly inside the server, right? So each HGX, which has typically 8 H100s in it, will have 1 to 2 BlueField 3s in it that are handling all of its data processing needs, right? Versus having an external compute layer. And so when you think about combining the BlueField 3 with some external, with the compute that sits in the data platform, now you have a very powerful dynamic environment where you can balance between vast database, vast data engine, and the high performance, scratch and file access needs that training workloads have. All right, just another slide talking a little bit about the deep BlueField integration. So the BlueFields will go inside the HGX servers. They essentially have direct access to our persistence layer, what we call our data layer. And by doing that, you get the performance advantage. You also have some very cool security advantages because each DPU is dedicated to the same tenant that the GPU server, the HGX, is dedicated to, right? So if you're in a multi-tenant environment, or you're in an environment where there's contention between workloads and different groups have their own isolated environments, you can leverage the vast data platform as a common platform underlying all of these workload environments. I'm going to talk a quick second about the data that feeds model training. And the simple answer is the data lives everywhere. The data lives in the public cloud. The data lives at your SaaS providers. You've got traditional data on premise. And when it comes to AI, as I said at the beginning, AI does best when it learns from a lot of different places. So one of the biggest challenges with AI model training is simply getting it fresh data, right? In many, many scenarios, and you'll see a lot of people talk about this publicly, the biggest challenge with AI model training is that they keep training the models on the same data. And when you do that, the quality of your results inherently suffer, right? They're not going to get better unless you can get the model's new data to look at. The problem with this, and your data being spread everywhere, is you spend an awful lot of time shipping your data around so that it can get to the right location. This is where vast data space comes into the picture. And in the demo, what you are going to see is you're going to see a scenario where there's data in AWS, there's data on premise. You're going to see model training take place across both of those. It's actually really cool because, as I mentioned, this is a moment detection, right? So you have a video clip. You ask a natural language query, find me when somebody scores a goal, or find me where someone goes and gets a cup of coffee, someone, walks up to a cash register, whatever your moment you're interested in. And the AI is actually able to go find that moment. The problem is, in order to be good at it, it needs to have access to a lot of different data. So that's why we felt that this was a really good way to demo the value of vast data space in the context of AI model training, right? So first of all, with vast data space, cache reads are extremely fast for obvious reasons, right? So you go start training a model, you prefetch some data, you're able to access that data. It's as if that data is sitting locally. But the traditional problem with global namespaces and distributed data approaches is that consistent writes are extremely slow. And the reason the consistent writes are extremely slow is because there's a lot of negotiation that has to take place between the various parties in order to efficiently do writes. So what VAST has been able to do through the innovation at our metadata layer is solve that problem of slow, consistent writes, right? Through a variety of technology, including the way in which we chunk up and subdivide our data, along with our distributed lock management, we are able to now have this concept of ownership and of loans and of sharing the lock and loaning out locks at a file level, an object level, table level, even a sub-file level. If you have large files, we can do this at the chunk level. So this ability to do fine-grained lease management means that we can go ahead and do AI training, right, model training off of data that lives in many different environments without having to pre-stage and pre-move that data. Right, so talking very briefly, as I described in the demo, you will see HGX sitting on premise, training on data that is located on premise. It is also training on data that is located in AWS. Once again, we're not pre-replicating, we're not pre-shipping, and you'll actually see a difference. We will show you through the Run AI UI what the storage access profile looks like as the job proceeds, and you will see a difference. But at the end of the day, being able to train across that large corpus of data without having to pre-move all of your data to one location is a huge advantage for many of our customers. Jesse, you want to talk about provenance and lineage for a second?
Yes, thank you, Niloy. So to many of you who follow the AI world, heard about the whole New York Times suing OpenAI because OpenAI was using New York Times data without actually getting permission to use it, right? This problem is going to get worse and worse. And what customers need to think about when they start modeling with data is about three things. One is to be able to say, where did the data came from? That is the data provenance part. Once you get the data, what do you do with the data, which is the data lineage part? And the third thing is, how do I connect both the provenance and the lineage to the history of how I created that model, right? Because in the legal world, these three things will be necessary to go and defend yourself if you're using any kind of an AI modeling framework today, right? Customers don't think about it, but large custom. And the other important thing to note is that most data for modeling comes from internal sources. It's not going to come from external sources. They still need to be able to do these things to be legally defensible on the models that they actually put out for customers to use. Next slide, please. So when you think about this thing, what we think about is a concept called a data set. A data set is an all-encompassing container kind of a field where you have data, that is the raw data, which has the provenance, and then we take the data, annotate it, change it so that you can use it in a model, and then model data gets run, modeling gets done on the model data, and then you iterate on this process, and there is at least one or two models out of that which is in production, right? To be able to do something like that, you need three things that I think we definitely need. One is a structure so you can follow the data from all the way from the raw form where it came from, the provenance, all the way to the model in production to be able to connect all those dots. That's structure. The second thing is a catalog, which basically records everything so that you can go and look at it. And the third thing is if a legal challenge arises to anything within the model, there is good reporting to say, hey, this piece of model came from this data, which came from this raw bucket, which came from this particular source, right? And as the data volumes get larger and larger, this is going to become really interesting for a lot of customers. There are third-party tools to do it today, but we at VAST think that you can do the entire thing within our VAST data platform. You don't need 10 different tools to do this, because doing it on a single tool means that it's consistent, whether you're doing it in on-prem, whether you're doing it in AWS, or wherever you're doing your modeling with the data that you have. Next slide, please. So what does structure really mean? Structure really means is it's a concept of a data set that I talked about, which has data tracked and lineage. Okay, which version of data came from which line of the back, right? Think about it more like a Git kind of a concept, right? You have the data, and every time you need something, you basically check out the data, you do something with it and check it back in. With lots of data, Git is not going to work. So you got to think about it differently. And that's where the whole structure comes into play, right? And this can be accessed by API, and then data can be accessed by, how AI works really well with NFS. You can model the data in SMB if you want to go change some things, or in S3 if you want to add tags to it, right? Those things can all be done in the structure. The other thing we didn't talk about is VAST database. Actually, one of the things that we do within the platform is take the VAST database and use it as a catalog to store all the file information within the same system, which is very different from everybody else in the marketplace, if you think about it, right? So what that means is that we have an instant access to the metadata of any file sitting on the system really instantly. So that allows us to build a catalog, which is consistent and real time, which is for most third-party tools, it will never be real time. For us, it's near real time, right? And the last thing is, how do I report on this one? Today, our reporting, as Jason talked about, we have MPP clients, Trino clients, Spark clients, and also Grafana that you can talk to the catalog and build any kind of reporting on top of it. And we're going to show that to you at the GTC next week. Right. So next is Rupert is going to talk about model. Okay, there you go. It's a question.
So yeah, I mean, this brings up the question, right? Have you already hit this issue with provenance? But I've been hearing in Europe is going to have a lot of different rules, but again, the New York Times thing, it really becomes an interesting legal question. And so it's all about, being able to curate data. The catalog is really interesting, kind of building a semantic layer across all those data sets. So it's pretty fascinating.
Yeah, I would add that, if you can think about one of the use cases of the catalog is you can actually have natural language queries built on top of it if you attach it to a GPU cluster.
That's pretty wild.
It's that simple, right? So
Totally
exactly, right?
Yeah.
All right, Rupert.
Okay, awesome. So, we tend to focus a lot in AI on the first three steps in the traditional data platform, which is data capture, ETL, where I will say that I think traditionally we spend 70% of our time on ETL. Cleaning data takes a lot of time, all that washing, because data is never captured clean. And then we have these huge machines we purchase, GPU powered, if you can get your hands on a GPU to then create a model. And all that just gives you a model. What do you do with this model? Isn't the whole point of capturing this data, cleaning it, and creating a model so that you can inference off the model? So it's interesting to me as an AI practitioner how so much focus gets into the first three steps. And the last step is almost like, oh yeah, let me just service the model. Well, would it be surprising to you that the inferencing stage is arguably about 10x to 100x, a factor bigger than the deep learning stage of the pipeline? Now, you would say that the models themselves are small. That's true compared to the amount of data that you're doing in deep learning. But all of that inferencing needs to happen on something, whether that's a CPU or GPU. Now, the queries, the prompts, and the responses might be small individually, but at scale, they're much, much larger, especially if you have to keep a repository of the different models. Remember, you're never going to have just one model. The models are constantly being updated. You're going to have repositories, versioning. All those prompts and responses have to be stored in case somebody comes and asks what was sent, who sent a prompt, all the audit around it, the audit logs, all of the machinery that goes around inferencing starts to make it a much larger infrastructure question than just standard deep learning. Can we go to the next slide, please, Milan? So what the industry is responding, there's the newer, more power efficient GPUs and CPUs available. We will talk to our partnership with Supermicro. The MGX is leveraging the GH200 from NVIDIA. We also have other options that you can use for inferencing. And we can talk more when you come by the booth. Next slide, please. So when you're talking about models, it's not just LLM models. You need to be able to service multiple different models for your use cases, whether it's vision, whether it's speech, natural language, it could be multiple different things. So you're going to have a platform. At the GTC booth, we're going to talk to you and show you a demo around Triton and how you can leverage Triton to basically do MLOps around your models, service your models, deploy your models, scale it up, scale it down, make use of the infrastructure you have in the public cloud or the private cloud to service customers for your models, and how you size it for those different aspects. What parts of the AI development are you going to incorporate into the model serving? How large do you want it to get? How small do you want to get? How do you actually do this in production once you have the models? And how do you tie together the data pipeline from the model creation, the model optimization, into the model serving? Think of this as the Netflix issue, right? As Netflix grew, they had to have thousands of different versions servicing different customers across the globe. You will have a similar situation when it comes to models, because you're going to have different models servicing different geographies due to different local sensitivities. You're going to have different models being versioned at any given time, and you're going to need something like a Triton or a platform to allow you to get your arms around it. Can we have the next slide, please, Nilay? That's next. Yeah. So how does that work? You do a lot of optimization. You create a model, you do optimization, it goes into a model repository. Model repository is just a place to store all these models. Models don't get big. There are some very large models out there. The GPTs and the LLMs traditionally today are some of the largest models easily available. There are also a lot of smaller models that are just as important and are highly specialized around vision or retrieval of text from video or video to text. You're going to have to be able to scale up those inferencing instances. Those instances might be leveraging GPUs or CPUs, depending on what you have available. It might be actually a hybrid, right? Some models are actually more efficient in some cases on a CPU, and in other cases, they're more efficient on a GPU. It just really depends on the different models and what you're trying to do with them. And then at the very end, then you're going to have an edge situation where your end user, they're coming in on multiple different platforms, going into some sort of enabled application that needs to leverage these models. So how do you do this at scale? When you come over to the booth at GTC, can you go to the next slide, please, Milan? We will show you a demo leveraging the vast data platform to be the one underlying layer for all of your inferencing. But keep in mind, this is just an extension of the vast platform you've already been using for data capture, for ETL or data preparation, for deep learning. And now you don't need a separate platform on the data level for your inferencing. You can leverage the exact same platform to now also satisfy your inferencing needs. You can leverage, in this case, our demos based off of Triton, but there are other frameworks you can use and plug right into our platform. You can run the Run AI MLOps. Again, there are other platforms, they plug right in. And you can use your MGXs for your private cloud or your DGXs or your CPUs to scale up and down. And so our demo is in AWS, so we can show you how it's operating. Prompts come in, responses go out. Those responses get stored to a data store on the VAST system. It's pulling models from the VAST system. All the while, that VAST system is still doing the other demos that are doing data capture, data preparation, and deep learning. All of this in the cloud on actual VAST software. None of this is a canned demo. It's actually running in the cloud so that you can see how it's operating. So that's it in a nutshell. Keep in mind, inferencing is the next big thing after deep learning. You need to understand how you're going to approach it. You need to understand how to get your arms around it and what you want to do when it comes to inferencing. The buck doesn't stop after you train a model. That's just the beginning of what you're trying to get done.
Cycle.
It's just step one.
Yeah, exactly.
Yeah.
All right. So one last poll question here.
Yeah.
We've actually had some pretty even distribution across of these, so I'm curious to see what happens for this one.
And I'm curious about this one. Is it a technological limitation that you aren't using RAG yet, or is it just it's somewhat of a newer feature that people are just getting around to implementing? What's your impression?
I'll tell you, not that I don't know if we're sharing the results yet, but the compared to the results of the other two polls, I think it overall reflects the maturity of the market, right? I think folks have been, the data preparation, the model training, that's really where the focus has been so far.
Right.
But as Rupert pointed out, that in and of itself does not add business value, right? The majority of business value from AI that's being extracted today is by inference on other platforms, right? Microsoft, OpenAI, et cetera, Midjourney, blah, blah, blah. So I really think, over the next year, certainly 18 months, I think if we were to have this conversation 18 months from now, we'd see a very different poll. But anyway.
And the point here is VAST is already answering this question, so that when you get to the point of saying, okay, I have a model, my customers have a model, I need to now service or provide inferencing on these models. We can tell you how you build that up and how you service those models using the vast data platform.
Absolutely. Yeah, that is right. If that has not come across here, that is the central theme, right? Across the entire AI pipeline, Vast has a singular data platform that can address all aspects of the AI pipeline. And candidly, we're just getting started, right? We love to collaborate with our customers, understand how better can we minimize data movement amongst customer in your environment, and whatever the answer there is, we're going to go do it. That's where we're focused on it.
And honestly, the fewer platforms that I have to administer and maintain, the better. That's just, I can get some sleep on weekends and the evenings. So
Yeah.
if
there's also a huge security aspect to it, right? Because it reduces the surface attack. We've got that zero trust banner across there, and that's something I think that within AI people have not thought about. You know, things like data poisoning. There's different attacks that are going to happen, and having a multi-tenant secure infrastructure is really important.
It's a single
Correct.
governance layer across the data store. I mean, so we talked about the you know, this multi-site solution under the same governance. So that's
we
really
have. Sorry, I didn't mean to go talk over you, Jason. I just get very enthusiastic and passionate when it comes to AI conversations. But we have 2 minutes. What I was going to say is, we didn't talk about it, we didn't touch on it in here. But to Stephen's point, I would have put that zero trust much higher up on the list. And not only that, I would have also said multi-tenancy and QoS are very important in this, because not only do you need to be able to store the data, you need to provide that zero trust on everything around accessing that data, but then you also need to have the multi-tenancy capability feature that Vast does, and the ability to QoS that data. And the important thing is none of this is static. You can change and dynamically allocate your tenancy, your QoS, and your zero trust as needed. So when you're not doing deep learning, transfer all the performance to the front-end inferencing. When that inferencing goes down, maybe your inferencing doesn't happen much at night, transfer all of that work into deep learning, all that performance and capability. None of it has to be static, completely dynamic, just like everyone's used to in the public cloud. And our system already has those features. In the near future, keep closed and join these webinars, because we have some really, really fun and exciting new features to make your life even more easier and allow you to scale faster and run better.
Yeah, and I think that's the big point, right? We're really moving towards this becoming, you know, moving from like a research phase into a product phase.
Correct.
Where, you know, enterprise companies are going to, but thank you, Philip, for that comment. Philip says, great presentation. And again, thank you for your questions. So again, this week was pretty staggering, and that's like just leading into GTC. So go ahead. I'm going to show you a QR code here on the next slide. And
just one quick point before we go to that. So thanks to our partners, as was mentioned earlier, this is a live full stack implementation, right? So at the booth, you can see recordings, you can do a live interaction. For those of you coming to GTC, you can obviously interact with us, and Steve will tell you how in just 1 second after GTC, or if you're not coming to GTC. But like Rupert raised a really good point, right? Being able to modify the quality of service settings in an environment during a training job, we don't do that in the demo. There's only so much you can do in one demo, but that is absolutely something we can do. And so, you know, if you swing by the booth, we can literally spin up a training job and start tweaking the quality of service settings on the platform, and you're going to be able to immediately see in the Run AI UI the impact to your the access to data your model has. So lots of potential for broadening just the things that we're demoing.
And if you're not making it to GTC, this demo is completely available to you through multiple different options, whether it's a live recording or a live schedule with us. Just reach out to whoever your point of contact is at Vast. Let them know your interest in seeing this demo, and we'll make it happen for you, however that works out.
And that's what this QR code is about. So click this. It's going to pop up and talk about, you know, arranging a meeting at GTC. Seems like most people in this call are not going to be here, but to Rupert's point, right, we are certainly glad to follow up and arrange a personalized demo for you. Again, like I said, we're building all this on the cloud, so it's easy for us to spin up, and then you can really dig in and help us understand more. So there was another really good question about what are we most excited about in GTC, and it really is hearing from you. We build this platform for you, and we just have an amazing engineering team that can respond to the questions. So it's, working with leaders like you that helps us get better. One more thing, as you exit, there will be an exit poll. It's going to ask you how you'd like to engage with us. Do you want a demo at the booth? Is it following up offline? So go ahead and answer that poll there. Question about, is the deck available for download? Stephen, reach out to us and we can help you with that as well.
Sure. Yeah.
Awesome.
Totally.
Well, team, everyone in this call has been crazy busy the past couple of weeks. So the fact that you all were able to take time and jump on here today, I'm so appreciative. And appreciative to our customers and partners that joined. Just very exciting time here with everything going on. And again, just reach out to us. More than happy to dig into any aspect here. And again, we appreciate your time today. So thank you, everyone. Hope to see you next week. If not, reach out and we'll set up a demo for you.